In this video we want to look at the behavior and properties of series circuits. So we started off with our discussion of circuits with a basic circuit that has a voltage source here. Let's say this is an 18 volt source, and there's some wire, conducting material here, and then we have a resistor, electrical device here. Let's say this resistor is a 10 ohm resistor. So just based on Ohm's law, we know the current is the voltage divided by the resistance, and so our 18 volts divided by our 10 ohms gives me a current running through this circuit. Current running through the circuit of 1.8 amperes. Alright, so just using Ohm's law, kind of figure out that information there. And this should be familiar if you did the lab in class. This is the results we got for one of the bulbs, and we had another setup, same 2-cell battery. We put another light bulb in, but this light bulb is a little bit different. This was a 5 ohm light bulb, and so the same process here. We want to find the current, and that would be our 18 volts still that we had for the voltage divided by the 5 ohms, and that gave us a current of 3.6 amperes. So just some very simple circuits here. Alright, these are the simplest circuits you can have, with just a voltage source, resistor, and then the wires or the conducting material connecting it all together. These are series circuits because there's only one path, right, for the actual charge to flow through. So when we talk about a series circuit, there's only one pathway for the charge or for current to flow. So we start combining these things together, right, make a more complicated series circuit where we put multiple resistors or light bulbs or any device electrically. So now we have a series circuit that has 2 resistors. Say we have our 10 ohm here and our 5 ohm. So we take these 2 light bulbs from over here, now I put them together here into series with each other, and so we still have 18 volts here, and the current is going to flow, and it only has one pathway that it can flow. It's got to go through one bulb, then the other bulb, and so on. If something were to happen and one of these bulbs were to get messed up, right, well, the bulb blows, it stops working, gets disconnected, well, then we have a gap there, and therefore we don't have the flow, right? The whole thing is gone then as a result. Now, put this back, right, we still have our flow. Let's fix the resistor back like so. Alright, so one path to flow. If one goes out, they all go out. Right? That's a real simple way of looking at the idea of a series circuit. If one goes out, they all go out in here. And so in doing this in the lab here, we've measured already that this was a 1.2 amperes worth of current. We measured it here. Measured here in between the bulbs, and also got 1.2 amperes of current. Measured over here and got 1.2 amperes of current. So we find in this process that we have the same current everywhere. And so we'll use this as our first characteristic. Of the series circuit. So we say that the current is the same everywhere in the series circuit. Circuit is the series circuit. The current is the same everywhere. So no matter where we look in the circuit, it's always going to have the exact same current. So all the charge is already there, and as a result, the charges in the field associated with it sense the entire circuit and all of its resistance at once, and so the current is the same everywhere throughout the circuit, no different anywhere. So first characteristic is the idea of current. And the next would be the voltage. So we look at the voltage. What happens to the voltage? We have 18 volts here. that's providing the potential difference for the current to flow through the circuit. But it's going to behave a little bit differently at each of these places here. If we look at this resistor here separate from this other resistor, right, our 10 ohm resistor, and we want to look at, well, what voltage would it have? Well, the voltage, when we look at that idea, we go back to Ohm's law, right? We have I equals V over R, and if we just do a real quick cross multiply here, right, that'll give me voltage equals current times resistance. So my voltage is my current 1.2 amperes times my resistance of 10 ohms. So that gives me 12 volts. So on this particular bulb right here, the voltage of 12 volts is being used. Right? We're converting electrical energy provided by the potential difference in the voltage source. We're providing electrical energy and we're converting it into light and heat in the case of the light bulb. So we're actually using about 12 volts of that energy. Well, since there was only 18 volts total, energy's got to be conserved. That would give us thought here, well, this should be 6 volts then. Right? 6 volts plus 12 volts is 18. And if we take that same thought process we had a minute ago here, our voltage should be our current 1.2 amperes times 5 ohms. You should get 6 volts when you do that. So the voltage is distributed proportional. When I say proportional, I mean using Ohm's law, proportional to the resistors. Right. So I could say that the total voltage of the source is basically equal to the sum voltage 1 plus the voltage going through 2 plus, and however many we might add to it. So we simply add up all these voltages here. And again, those voltages are simply the current times resistance for that. So it might be a situation where you're able to measure each of those like you did in the lab, add them up to get the total, or maybe you have the current and you work backwards and find the voltage there. The voltage is going to be distributed amongst all the different resistors in there. All right, there's only one path. All that energy has to be shared within that one path. All right, last for this would be the resistance. All right, and so the resistance, we talk about this. All right, the total resistance of the circuit. Total resistance is simply the resistors added up. So we have just simply add up all the resistors. That gives you your total resistance that you have in the entire circuit. So in this case we have 5 ohms and 10 ohms. So our total resistance should be 5 plus 10, which is 15. Right, so that's 15 ohms as a total resistance. And we can check this based on everything that we have here. We know the current throughout the circuit is supposed to be 1.2 amperes. We know the voltage is 18 volts. All right, and Ohm's law solving for resistance is voltage divided by current. And so our total resistance then could be a voltage of 18 volts divided by 1.2 amperes, which gives me 15 ohms, which is exactly what it's supposed to be by simply adding them together. So for a series circuit, we know the current is the same everywhere in the circuit. We know the voltage is distributed proportional to the resistance, so we simply add up all the voltages to get our total, and then our resistance, same idea, we add up all the resistors and it gives the total resistance of the circuit. So that's the basic behaviors of a series circuit.